Humans have lived in caves since the very beginning. North America has 70,000 caves where humans took shelter. The problem is that another animal liked caves too. On the scale of time, roughly 12,000 years ago, humans and Arctodus lived side by side. Back then, North America held creatures far larger than anything alive today. Panthera, Smilodon, Enochion, mammoths everywhere, and one animal that challenged them all. Arctodus, a 1-ton giant, so big and so heavy it could hunt even mammoths. This powerful carnivore could consume up to 110 pounds of meat in a single day, which means humans were competing with this animal for meat.
So how big was it, really? Why did evolution produce a bear of that size?
And what happened when a human band and this animal wanted exactly the same thing?
To understand Arctodus, you first have to understand the world it lived in, and that world looked nothing like America today.
During the Pleistocene, the North American continent supported an amount of animal biomass that is hard to imagine now. On the plains there were Columbian mammoths, which could exceed 9 tons. In the wooded areas, mastodons. There were bison larger than any living bison, with horns spanning almost 7 feet from tip to tip. There were native horses, because the horse evolved in the Americas and lived there by the millions before vanishing from the continent. There were American camelids, giant ground sloths the size of a car, and beavers that reached 220 pounds.
That was the setting, an entire continent built on a larger scale.
And that is what explains the size of Arctodus. Large carnivores are expensive. The bigger the body, the higher the energy cost. There is an ecological ceiling on the size of a land mammal that depends on protein, and that ceiling is set by the environment, not by the animal.
For a bear weighing well over 1,000 pounds to exist, everything around had to be gigantic, and it was.
A landscape populated by mega herbivores is also a landscape permanently littered with carcasses. Animals weighing several tons die constantly, from disease, age, injury, getting mired, drowning, and cold. For a large animal with a keen sense of smell and the ability to cover long distances, that worked like a food network spread across an entire continent.
Now, where did this lineage come from?
Arctodus belongs to a group called the Tremarctines, the short-faced bears. That group arose in North America a few million years ago, from forms similar to the genus Plionarctos. When North and South America connected, part of that lineage moved south and gave rise to the South American Arctotherium. In other words, a single family of bears produced the 2 largest bears this planet has ever known, one on each continent. And out of that entire family, one species is left today, the spectacled bear, that same 220-pound animal that appeared at the beginning of the video, hidden in the Andes, mostly vegetarian and threatened with extinction. It is the last living representative of a lineage that once put 2 giants on their feet across the American continent.
But let's come back to size, because numbers alone communicate nothing.
An American black bear weighs between 130 and 550 pounds. A large brown bear falls between 650 and 880 pounds. And a well-fed coastal Alaskan brown bear can top 1,300. An adult male polar bear generally weighs between 770 and 1,300 pounds, with exceptional individuals approaching a full ton.
Look at the comparison. Each of these animals is, in its own environment, a dominant predator, and each is successfully larger than the last. Arctodus simus sits above all of them.
Estimates for large males fall in the range of 1,300 to 1,750 pounds, with exceptional individuals estimated near 2,000 or more. Females were considerably smaller because sexual dimorphism among bears is pronounced. To put that in everyday terms, this animal's body weighed roughly the same as a compact car. An adult human weighs about 155 pounds. The difference between the two is roughly tenfold.
And there is one detail that completely changes the silhouette: the legs.
Arctodus had long limbs relative to its body. It did not have the low, compact build associated with the brown bear. It was a proportionally taller animal with a long stride and a more upright posture. From a distance, its shadow against the horizon would not immediately be recognized as a bear's. Arctodus is the largest bear a human being ever had the chance to encounter, but size alone does not explain what made this animal dangerous.
And here the science has changed significantly in recent decades. For a long time, the popular image of Arctodus was that of a specialized super predator.
The logic seemed solid: long legs, an enormous body, an apparently short snout. The classic interpretation described a pursuit hunter capable of running down prey in open country. An alternative version described a dominant scavenger, one that used those legs to cover enormous distances locating carcasses and simply drove any other carnivore off the site. Isotope analyses of Alaskan specimens reinforced part of that image. Those far northern individuals showed a strongly carnivorous signature, but later studies complicated the picture. First, the so-called short face turned out to be, in large part, a matter of proportion. Skull analyses indicate that the appearance results largely from the overall size of the head, not from an extreme specialization. Second, the architecture of the jaw and teeth is not that of a specialized bone crusher, nor that of a dedicated hypercarnivore like a hyena. Third, the isotopes do not tell the same story in every region. Different populations show different dietary patterns. An Arctodus from Alaska and an Arctodus from California were not eating the same thing. And there is a simple argument that carries a lot of weight. Bears in general are opportunists. They eat what is available: meat, carrion, fish, roots, fruit, grubs, honey, depending on the season and the region. The most likely reading today describes a large-bodied omnivore, flexible, with a variable diet, capable of consuming large quantities of meat when it was available, including meat it did not kill. That may sound less impressive, but from the point of view of a human band, it is significantly worse. A specialized hunting predator would have a simple relationship with humans. It would see us as prey. That is dangerous, but it is predictable. A 1,500-pound opportunistic omnivore, with a bear's sense of smell and a territory of 100 square miles or more, creates a different situation. Its interest is not the person, it is the food that person just managed to get.
And that completely changes the kind of encounter that took place.
To understand that encounter, it helps to lay out the food chain of Pleistocene North America. At the base were the grasses, shrubs, and vegetation of the cold steppes, which covered immense areas of the continent and produced food in quantities that America no longer produces. Above them came the large herbivores: mammoths, mastodons, bison, horses, camelids, giant sloths. They were the ones converting all that vegetation into tons of circulating meat. At the next level came the medium-sized social carnivores: dire wolves in packs, coyotes larger than today's, mid-sized cats. Then came the large specialized predators: Smilodon, built to bring down big prey with a precise bite; Homotherium, the American lion, which could exceed 650 pounds.
And then, occupying a place that is hard to classify, Arctodus.
It is important to be precise here. It probably was not an apex predator in the classic sense, because it likely did not hunt most of what it ate. But in any direct dispute over a carcass, it almost certainly had the last word. A 1,500-pound animal that arrives at a spot where there is food does not need to negotiate with wolves, and probably did not need to negotiate with a Smilodon either. It was not at the top of the food chain, it was at the front of the line.
And this is exactly where our species enters the story.
At least 15,000 years ago, and possibly much earlier than that, small human groups entered North America. They were bands of a few dozen people, carrying hides, stone points, fire, and knowledge accumulated over generations about surviving in cold environments. For a long time, the standard archaeological account identified the first Americans with the Clovis culture, present in North America around 13,000 years ago. That account has changed. Today there are sites pointing to earlier human presence: Monte Verde in Chile at around 14,500 years, Paisley Caves in Oregon, Cooper's Ferry in Idaho with dates exceeding 15,000 years. And there is older, still debated evidence such as the human footprints at White Sands, New Mexico, dated by some researchers to more than 20,000 years.
On the other side of the ledger, the less reliable records of Arctodus simus fell around 12,000 to 11,000 years ago.
Even using the most conservative dates for human arrival, that leaves an overlap of more than 1,000 years. 1,000 years of human generations being born, growing up, and dying on a continent where this animal existed, in the same valleys, along the same rivers, around the same carcasses. Which raises the inevitable question: if a person met an Arctodus simus, what would their chances be? To answer that, you first have to discard the image of the chase. A human runs at between 6 and 9 miles per hour. A modern brown bear, at half the mass of Arctodus, exceeds 30. There is no realistic scenario in which fleeing across open ground works.
You also have to discard the image of a physical fight.
In mass, the difference is roughly tenfold. In brute strength, there is no comparison. A modern brown bear drags carcasses weighing half a ton and breaks long bones with its jaws. In natural weaponry, the difference is absolute, because a human being simply has none. Human nails and teeth are useless in combat. In resistance to injury, the fat layer, the musculature, and the thickness of the hide put any 150-pound mammal in a different category. For a lone person, unarmed, and surprised at close range, the probability of survival would be extremely low.
But no human being of the Pleistocene lived that way.
And this is where the comparison changes completely. An Arctodus is a solitary animal. 30 human beings are not 30 individuals. They function as a single unit. They attack at a distance with spears and atlatls, doing damage at 60 or 100 feet, while the bear has to get within arm's reach. They communicate, coordinate positions, and alert the entire group within seconds. They plan, choosing where to camp, where to store meat, and when to move. They control fire, something no other animal in that ecosystem possessed, and they accumulate knowledge across generations about where that animal tends to show up and what must never be done.
The real confrontation then almost never happened as a confrontation.
The more likely scenario was different. A human group kills a large herbivore or finds an animal already dead. That represents hundreds of pounds of meat, fat, marrow, hide, and bone, and it can mean the difference between getting through the winter and not getting through it. But processing an animal that size takes hours, sometimes more than a day, and that whole time, the smell travels with the wind. The wolves arrive first, then possibly a big cat, and at some point on the horizon, an animal appears that is far larger than that group could face head-on. The human response was not to fight. It was to make noise, stay grouped together, use fire, throw objects from a distance, and, if necessary, abandon the meat and withdraw. Arctodus probably did not kill humans often. What it did was make human life permanently more expensive, and adding dire wolves, saber-toothed cats, and American lions to the same environment, the entire continent charged a daily toll in attention and energy. This was one of the last ecosystems on Earth in which being human still meant sharing territory, every single day, with an entire community of dangerous megafauna.
What came next?
The end of the last ice age was not a smooth, uniform warming. It was a period of violent climatic swings, with abrupt temperature reversals, including the event known as the Younger Dryas. And along with the climate, the vegetation changed. The mosaic of grass-rich steppes that sustained the great herds began to fragment. In many regions, it was replaced by forest, wetland, and tundra, environments far less productive for mega herbivores. Less grass means fewer mammoths. Fewer mammoths, fewer bison, fewer horses, and fewer camelids means less meat circulating through the whole system.
And here's where the trap closes on an animal like Arctodus.
It needed an immense territory. It needed a constant flow of high-quality food. It already had a naturally small population. It had slow reproduction, few cubs, and a long interval between generations. Species that are large, rare, and slow breeding are precisely the ones least able to tolerate a drop in the food base. There is no margin for error. And in the very same period that this base was shrinking, a new factor entered the system. Human populations expanding, hunting the same large herbivores, occupying the same valleys, disputing the same carcasses, and probably eliminating large carnivores that came too close to their camps.
Which of these factors was decisive?
That is one of the longest-running debates in paleontology, and it remains open. There are researchers who give more weight to climate. There are those who give more weight to human hunting. And there is an intermediate position, quite strong today, according to which both factors acted together, and human pressure was devastating precisely because it arrived when populations had already been weakened by the transformation of the environment.
What can be stated with confidence is simpler than any of those positions.
The world that made a bear of that size possible was ceasing to exist, and Arctodus faced an adversary that could not be intimidated by size, driven off by a roar, or beaten in a dispute over a carcass. The transformation of the continent itself. Around 12,000 to 11,000 years ago, Arctodus simus disappears from the fossil record, and it does not disappear alone. In that window of time, extremely short on a geological scale, North America loses most of its giant animals. The mammoths, the mastodons, the giant sloths, the native horses, which would only return to the continent thousands of years later, brought in on ships, the American camelids, Smilodon, Homotherium, the American lion, the dire wolves, the giant beaver. What remained is present-day America: brown bear, black bear, moose, deer, modern bison, cougar, gray wolf. A fauna that is still impressive, but that represents what was left of something considerably larger.
As happened with so many other giants, the bones remained.
Fossils of Arctodus simus turn up across an enormous area, from Alaska and the Yukon down to Mexico, passing through California, Nevada, Indiana, and various other states. They have been found in caves, in river deposits, in natural traps, and in the frozen sediments of the far north.
But there is an important detail in that record. It is relatively sparse.
Compared with other animals of the same period, Arctodus is uncommon in the fossil record, and that is not an accident. It is exactly the pattern expected for an animal of that size, with a low-density population, enormous territories, and few individuals per area. It was never abundant. It was an animal you could go months without encountering. That scarcity also explains why the weight estimates vary so much. Much of what we know comes from incomplete skeletons, and reconstructing the weight of an extinct animal from isolated bones requires comparative methods that produce different results. Some methods start from the circumference of the long bones, others from skull proportions, others from direct comparisons with modern bears. Each one delivers a number, and that is why the estimates swing between a few hundred pounds and nearly a ton. None of those numbers is a measurement. All of them are reconstructions, and this is where this story parts ways with nearly every other one. Of most large extinct animals, all that exists is bones. No human being ever saw a Tyrannosaurus. No civilization recorded the existence of the great reptiles of the Mesozoic. There is no painting, no account, no memory. With Arctodus simus, the situation is different. Someone saw this animal. Someone stood a few feet from it and survived to tell about it. Someone came back to camp that night and described, around a fire, the size of the thing that had appeared on the riverbank. That story was told, probably many times, and probably for generations. Then it was lost. The account did not survive. No painting remained. No original name reached us. What was left was bone, sediment, and estimate. And what remains is the strangest fact in the whole story. For a few thousand years, somewhere in North America, there were people who knew exactly what to do when this animal appeared on the horizon.
We are descended from those people, and we were the only ones to forget.